Welcome to the lesson on multiplying and dividing fractions. In this lesson, we will take a look at the reasons why we will multiply and divide fractions and some of the basic steps in order to do so correctly. Let's first take a look at the essential definition behind this lesson. Like integers, fractions can be multiplied or divided. And in many ways, we think about multiplying fractions as finding a part of an already existing part, finding a fraction of a fraction. Dividing fractions can be interpreted as how many parts will fit into another part, as in a fraction of another fraction. Before we go any further, let's take a look at this visually and let's picture it. So let's imagine that we have a pizza, and this pizza has 8 slices or how many slices, and in this pizza we have a certain amount of slices left and we're trying to divide that between 4 people. We're trying to make sure that everybody has an equal share of whatever's remaining of a pizza. So think of how we write it. Let's say we have 4 slices left and we're trying to divide it between 4 people. Well, 4 slices is not an entire pizza. So 4 slices of an 8-slice pizza would end up being 1/2. So if I take that 1/2 and multiply it by 1/4, I'll be able to understand and figure out how much of whatever's left of my pizza can be split up equally between those 4 people. Rewriting this, I can put the 1/2 times the 1/4 and do the basics of multiplying fractions. Numerator times numerator, denominator times denominator, giving me a 1/8. Now, besides this example, why would I need to multiply fractions? Well, imagine I have a rectangle or a wooden plank that measures 3/4 of a foot on one side and 2/3 of a foot on the other. What would the area of my wood be? What would the area of this section be? What if we weren't dealing in feet but in miles? How would I find this out if I needed to continue to multiply fractions? Let's take a look at that example then. 3/4 times 2/3. You can set up the problem in much the same way regardless of how it's written and multiply my numerators. 3 times 2 in this case will give me a 6. Multiply the denominators. 4 times 3 in this case will give me 12. Now 6/12 does reduce down to a 1/2 or 1/2. Imagining dividing fractions might end up being a little bit different. So let's picture it so we can get an understanding. Think about if we had a cup, which is 1/8 of a gallon, and I want to figure out how many cups would go into an already half gallon where I have 1/2. So 1/2 divided by 1/8. In order to divide these fractions, I can set up another multiplication problem where I flip one of my fractions, 1/2 turning into 8/1. Multiplying the same way, I would get an 8/2, which of course reduces down to a 4. Let's take a look at another example so that we can better clarify this issue. Let's imagine I have the fraction 5/8, and I want to divide that by 4/3. I'll do the same thing, 5/8 times 4/3, the second fraction flipped, and multiply it to get 20/24. This, of course, can be reduced into a 5/6. The connection between multiplying and dividing fractions would end up being having to help us find parts of parts for measurements or combining big quantities.